we're going to try to figure out, are these different pairs, are they constitutional isomers, or are they identical compounds? And so the best way to do that is to pretty much try to name them. So this first one I can see is a straight chain. I've got 1, 2, 3, 4, 5, 6. So now that guy is just going to be hexane, if he has 6 here. And this one, let's see if we can find the longest continuous chain. I've got 1, 2, 3. Remember how to find the longest continuous chain. Start your pencil on 1 carbon, and then move along the bonds until you reach the end. Let's see, so I've got 1, 2, 3, 4, 5. So I wasn't able to get that guy in the longest continuous chain without either backtracking or picking up my pencil to go back there. So this guy is going to have a methyl group. So his main chain is pentane is 5. 1, 2, 3, 4, 5, which is different than this. This is definitely hexane. This is going to be 2-methyl pentane. Let's see about this next one. So these would be isomers. These are called constitutional isomers. They have the same molecular formula. They have the same number of carbons and hydrogens. They just have different bonding. So that this guy does not have a straight chain. This one does have a straight chain. So because of that, they become constitutional isomers. So I'm just going to write isomers here. This one, let's see, trying to find the longest continuous chain. I've got 1, 2, 3, 4, 5, 6. Again, hexane. Let's see about this guy. 1, 2, 3. It's really easy to stop there and be like, well, that's what's horizontally written on the page. But I can keep going because I don't have to pick up my pencil. So I've got 1, 2, 3, 4, 5, 6. So these are just straight chains of hexane. So these guys are going to be identical. They're the same molecule. They have a different conformation. Conformation just means you're rotating around those single bonds. And you have a different orientation in space, but you have the same connectivity. They have the same bonds. I have 6 carbons in a straight chain. I can rotate around those single bonds and make them look a little bit different in space, but at the end of the day, they would have the same name. They're both just going to be hexane. And this last one, let's see what we get here. This guy has 1, 2, 3, 4, 5. So he's going to be a pentane with a methyl group. And this guy has 1, 2, 3, 4. Okay, let's see if there's any other ways I can go. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Any way I do it, I'm only going to get 4. So this guy's parent name is going to be butane, and I'm going to have 2 methyl groups off of that. This one would be pentane. 1, 2, 3, 4, 5. Yep, pentane. So this is 2-methyl pentane. This is 2, 3 dimethyl butane. So these are going to be different. They're going to be isomers. These are constitutional isomers. So again, isomers are going to have the same molecular formula, just different bonding.